This is definitely question 12A is a calculator question. 3.1 to the power of 4 means this. 3.1 to this. But we should have 4 of these. I've worked it out on the calculator already. Right, this one. Right, it's across the bracket, so it's timesing, isn't it? So that'll be p to the power of 6. Right, this question looks a bit messed up, but I'm guessing it's this question. Like that. Alright. If I was to rewrite this, right, there's different ways of looking at this. If I was to look at it like this, 2 to the power of 3 means t times t times t. You can see there's a t over here and there's a t down there. They can cancel, right? There's nothing else that cancels, so you're just left with 8 over t times t, which is t squared. Right, the other way of looking at it is like this, but you can put the 1 there. Right, the other way you can do this is by looking at rules of indices. Right, t to the power of 1 divided by t to the power of 3. Remember, if the base is the same and you're dividing, what are you going to do to the indices? You're going to subtract, right? So it's going to be 1 take away 3. Not 3 take away 1, from the top to bottom. 1 take away 3 is minus 2. So that would be 8t to the power of minus 2. Now this thing over here is actually the same thing over here, as the same as this. You could represent t to the power of minus 2. Right, if you don't like negative powers, you can bring it down to the denominator. So you'll just have t to the power of positive 2. Right, last question. Question D. Two to the power of 3 times 2 to the power of something to give you 2 to the power of 9. Find the value of n. Well, you know, if the base are the same and you're timesing, you'd be adding the indices, wouldn't you? You'd be adding the indices to get the 9. So it'll be 3 plus n to give you the 9. Obviously n has to be 6, and 6 has to go there because 3 add 6 gives you the 9. So n is equal to 6.